So today, we're going to do a bit of a forensic investigation. We're digging into a crisis that really brought a major Canadian city to its knees. We are peeling back the layers of earth and concrete and time to figure out why a critical water main, this thing was the lifeblood for Calgary, didn't just fail once, but twice. And the second time, well, that's where the real mystery begins.
To really get a handle on the stakes here, you only need to know this one number, 60%. That's how much of Calgary's entire water supply was just gone. When the Bearspaw South feeder main ruptured, this wasn't just some little leak. This was a severed artery for the entire city.
And right here, this is the heart of the mystery. You see, the city was using this really advanced acoustic monitoring system. It's literally designed to listen for the tiny, telltale pings of a pipe that's about to break. But in the months leading up to that second massive failure, the system heard nothing. Not a peep. The pipe just gave way. How on earth does that happen? Well, that's what we're here to figure out. Okay, so let's set the scene. We're going to rewind the clock to June 5th, 2024. This was the day the crisis kicked off, and a city of over 1 million people had to learn very quickly just how fragile their world really was. This was a sudden, explosive failure. A local state of emergency was declared almost immediately. The city went into full-on conservation mode with stage 4 restrictions. That meant no outdoor watering, taking shorter showers, every single drop counted. And when the crews finally managed to excavate this enormous pipe, they found the culprit. About 200 of the high-strength steel wires that are supposed to hold it all together had just snapped. It was like the pipe's entire skeleton had shattered from the inside out. So what exactly is this pipe that caused so much trouble? To really understand why it failed, you gotta understand the technology itself. And back when it was installed in 1975, this thing was considered an absolute marvel of engineering. It's called pre-stressed concrete cylinder pipe, or just PCCP. And you can really think of it as a city's main concrete artery. The whole design is pretty ingenious. It combines the different strengths of concrete and steel to create this super strong pipe that was expected to last for 100 years. But, spoiler alert, this one barely made it to 50. Now, the way this pipe is built is the key to this whole story. You start with a concrete core, right? And concrete is great at resisting being squeezed. Then, it's wrapped with these incredibly tight steel wires, which are perfect for handling the outward pressure of all that water. And then, this is the crucial part, it's all covered in a protective layer of mortar. That mortar has one job and one job only, to shield those vital steel wires from the outside world. Remember that part. It's going to be important. All right, let's dive into the forensics. We've seen the what happened. Now let's get into the why. This is where all the evidence starts to tell a really fascinating story about a hidden flaw, a chemical culprit, and a slow-motion collapse that was decades in the making. So again, PCCP is this brilliant partnership. You've got concrete handling the compressive force, and then you have those tension steel wires handling the force of all that water pushing outwards. The entire system, the whole design, relies on those wires keeping their strength and their tension. If they go, the whole thing goes. And here it is, our first major clue in the investigation, what you might call the pipe's hidden birth defect. The specific type of steel wire they used back in the 70s, known as Class 4 wire, was made using a process that made it stronger, sure, but it also left it incredibly vulnerable to a very specific, microscopic kind of attack. And that attack has a name: hydrogen embrittlement. Honestly, the easiest way to think about it is like osteoporosis for steel. These tiny little hydrogen atoms from the soil sneak their way into the steel itself, and they make it incredibly brittle. The steel basically loses its ability to stretch or bend, and instead it just snaps. Like glass. This 3-step process is what makes it so dangerous. First, the hydrogen atoms get in. Second, they lock the steel's internal structure in place. And then, under the immense tension it's always under, the wire simply can't flex anymore. It just snaps, cleanly. No warning signs, no stretching, just a sudden, catastrophic break. So that leads to the next big question, right? This pipe had this vulnerability its entire life. Why did it suddenly start failing after 5 decades of just quietly doing its job? What was the trigger? And the answer, believe it or not, is something you would never suspect: road salt. For decades, the city had been salting the major roads that ran right over this pipe. That salt slowly seeped down into the soil, creating this corrosive brine that, over time, just ate away at that protective mortar coating we talked about. And once that shield was gone, the vulnerable steel wires were finally exposed to the hydrogen in the ground. So the city finds the broken section, they identify a bunch of other hotspots, and they spend the entire summer of 2024 making repairs. Everyone thought the crisis was over. But the pipe, well, it had another, much more terrifying secret waiting in the wings. I mean, just look at this timeline. It's really a story of false hope. After that first break, the city finds and repairs 29 other damaged sections. In September of 2024, they declare the mainstay stabilized, and they put it back into service. And for over a year, everything was fine. Until December 30th, 2025, when it all happened again. And this brings us right back to that central mystery, the silent failure. Remember that acoustic fiber optic system? It was designed to hear the ping of a wire snapping. The whole theory is that you can count these snaps and predict when a collapse is coming. But what happens if the pipe starts to fail in a different way? What if the wires aren't just snapping, but are slowly being thinned out by widespread corrosion? Well, that process is silent. The monitoring system was listening for the wrong kind of problem. It was completely blind, or I guess deaf, to the real danger. So now let's zoom out for a minute, because it turns out Calgary's nightmare isn't some isolated incident. It's actually just one chapter in a much, much bigger story of aging infrastructure all across North America. This specific type of pipe, PCCP from that era, is basically a serial offender. Just look at San Diego. They had so many failures, they ended up relining over 80 miles of it. The big utility in Maryland, WSSC, has also documented these exact same kinds of silent failures that their acoustic systems completely miss. Detroit's had its own major breaks caused by different environmental issues. You look at this, and the pattern is just undeniable. So after all this, what's the final verdict in our investigation? And maybe more importantly, what does this whole catastrophe mean for the future of Calgary? And really, for cities just like it everywhere? Well, first, let's talk about the cost. Just patching up the problems from these two breaks has cost well over $60 million. And that's not a long-term solution. That's just the reactive repair work. It is an incredibly expensive Band-Aid on a problem that is not going away. And this quote, I think, says it all. That second, silent failure fundamentally changed everything. It was the moment the city realized they could no longer afford to just sit around and wait for a warning sign that might never come. The risk of relying on a single, aging, and totally unpredictable piece of infrastructure was just too high. And that realization leads to the only real solution: redundancy. Calgary is now in the process of building a completely separate parallel water main. The goal is simple: eliminate single points of failure. Make sure that if one pipe ever fails again, there's another one right there ready to take its place. It's a huge shift from just monitoring a fragile asset to building a truly resilient system. And that leaves us with this one last thought. The story of Calgary's water main is a huge warning sign. It's a reminder of this vast, complex, and aging world of infrastructure that's hidden just a few feet beneath our feet. And it really makes you wonder, doesn't it? Is your city's infrastructure also living on borrowed time?